Today we're starting 2.2, Properties of Quadratic Functions in Standard Form. Some of the vocabulary we're going to talk about: Axis of Symmetry, Standard Form, minimum value, and somehow maximum value got deleted. When you transform quadratic functions in the previous lesson, we saw that reflecting the parent function across the y-axis made the same exact function. That shows that parabolas are symmetric curves. The axis of symmetry is the line through the vertex of a parabola that divides the parabola into two congruent halves. Algebraically, what we're saying is if we have a times quantity of x minus h squared plus k, the axis of symmetry is x equals h. You're going to see me writing AOS. When I write AOS, that stands for axis of symmetry. When you graph the function, it's a dotted line that goes through the vertex, cutting it in half. The reason why I have those things highlighted, why do you think so? Those are the important things you probably should write down. Here I have f of x equals x minus 3 squared plus 1. We want to identify the axis of symmetry. The axis of symmetry is always x equals h. What is your h in this problem? 3. So x equals h, x equals 3. That's your AOS. If I take this and graph it, x minus 3 squared plus 1. There's your graph. You can see that the parabola would be cut in half right here, correct? It passes through x equals 3. Remember from Algebra 1, x equals a number are vertical lines, y equals a number are horizontal lines. So this line, this axis of symmetry, is what cuts it in half. The axis of symmetry always is going to pass through this point down here. What is this point called? What's this point down here called? Vertex. When we talked in Algebra 1 about linear functions, you had your slope-intercept form, your point-slope form, and your standard form. Right now we know vertex form. Vertex form is a times quantity of x minus h squared plus k. Now we're going to talk about standard form. Standard form in quadratics is ax squared plus bx plus c, where a is not equal to 0. I have a not equal to 0. What would happen if a was 0? What would happen if a was 0? Not the entire thing. If a is 0, 0 times anything is 0, so this term would not be there. You'd just be left with bx plus c, which is a linear function. By taking out the a, it gets rid of being quadratic. So a is the only one that's not allowed to be 0. B can be 0, c can be 0, but a cannot be. The coefficients, a, b, and c, those are the numbers that are in front of the variables. They can show you the properties of the graph of the function. We could either learn the shortcuts, how to take standard form and get what we need out of it, or I could show you how to rearrange everything that it'll tell it to you. Right now I'm just going to show you how to rearrange things. If we had vertex form, a times quantity of x minus h squared plus k. What does x minus h squared really mean? X minus h times x minus h. That's what a squared means. Now if I were to FOIL this, x times x, x squared, x times negative h, negative xh. Negative h times x, negative xh. Negative h times negative h is positive h squared. The negative xh and the negative xh become negative 2xh. So if I take this and expand it, so when I expand this, I get x squared minus 2xh plus h squared. Now when I distribute this a to all three terms, I have a times x squared minus a times 2xh plus a x squared plus k. If I expand a little bit further, ax squared plus negative 2ah plus ah squared plus k. Now this sort of looks like this. Here's the important thing to write. I have f of x equals ax squared plus bx plus c. That is standard form. If it's in standard form, each one of these variables, each one of these coefficients stand for something. A is equal to A. A in vertex form is that number that's outside of the parentheses. The number outside of the parentheses multiplying in is your stretch compression. For the B, when you have negative 2AH, I got that from right here. The B came from right here. There's an H in the problem. An H can tell me what the AOS is. I could do a little rearranging. If I want to get H by itself, I have to move these two things, right? What are these two doing to H? Multiplying, so I have to divide them both over. So H equals B over negative 2A. So we know the AOS, the axis of symmetry, is going to be x equals negative b over 2a. The AOS, if you're given standard form, is negative b over 2a. Now we're talking about C. C doesn't have an x attached to it. So if I made x 0, and I put in 0 for x, you're left with negative h squared, which is just h squared. Ah squared plus k. This right here is your y-intercept. This one tells you stretch compression. This one here helps me find the y-intercept. This one here will tell me, sorry, not y-intercept, the AOS. This one will find the y-intercept. This is everything in the past 3 slides on one. If the A is positive, it opens upward. If A is negative, it opens downwards. Another way to think of that, if A is positive, the parabola is happy. If A is negative, the parabola is sad. The AOS is always x equals negative b over 2a. To find the vertex, remember the vertex is h comma k. If I take h, put it into the function, it'll find k for me. And the y-intercept is always c. Determine whether the graph opens upward or downward for 2x squared minus 4x plus 5. Where do I look to determine if it opens up or down? I look at the A. The A is right there. Is it open upwards or downwards? Why is it upwards? Because it's positive. That's what I told you on that one slide. If it's positive, it goes upwards. Negative goes downwards. the axis of symmetry. The axis of symmetry, we already said what the shortcut is. X equals negative b over 2a, correct? Because I did all the rearranging with the letters, I have negative. What's your b? Your b is negative 4. So I have negative 4, 2 times, what's your a value? Your a value is 2. What's negative 4? Positive 4. Positive 4. 2 times 2 is 4. What's 4 divided by 4? 1. What this is saying is that the AOS is going to be x equals 1. If we're to graph this parabola, that means if I drew a dotted line through negative or through positive 1, it's going to cut the graph in half. And I know the graph has to go this way because of the positive. Part C, we're going to find the vertex. To find the vertex is always h comma k. We already know that h is 1 because of this. Now what we're going to do, this is x. Remember, it's x comma y. I take this and put it into my function. F of 1. 2 times 1 squared minus 4 times 1 plus 5. All I've done is taken that h, substitute it into the function, and now I'm going to solve. What's 1 squared? Times 2 is? What's negative 4 times 1? Negative 4, then plus 5. A lot of you are going to go 2 minus 4 plus 5. But you learned a bunch of properties in Algebra 1 that says I can flip things around. 3 plus 5 and 5 plus 3 are the same thing. Here's what I do. I take 2 and I take 5. My positive numbers, put them together. What's 2 and 5? 7. Now I have a negative 4. What's 7 minus 4? That's a lot easier than going, what's 2 minus 4? Negative 2. What's negative 2 plus 5? 3. It's a lot easier putting all the positives together, all the negatives together, and then just do the subtracting once. How'd I get this 2? 2 times 1 squared. 1 squared is 1. 1 times 2 is 2.
Wait, so why do you just have HK?
What's the y-intercept? 5. Where'd you get that from? It's C. The number that's by itself is always the y-intercept. It's graphing it. I'll show you. 2x squared minus 4x plus 5. When you graph this, I could take and put, I could do the AOS x equals 1's a vertical line going straight through 1. You can see here that it crosses around here. It's hard to tell what number that is. So I'm going to go second graph, and I can tell that at 0, it is 5. All right, upward or downward?
Downward.
Why is it downward? The A is negative. If you need to do this up top, A equals what? A equals negative 1. B equals negative 2. C equals 3. if you need to do that right off the bat, A, B, C, you should not have any x's up there. A few of you had the mistake of putting x squareds. The number that is assumed is here is a 1. We just don't write it. Just like if we have the number 5, we don't put that it's positive. We don't put that it's over 1. We don't write that it's the first power. We don't write that it's a decimal with a bunch of zeros after it. They're just things that we assume automatically are there. The axis of symmetry. The axis of symmetry we said was negative b over 2a. Negative, what's b?
2.
Negative 2. You still need the negative out front. It's negative whatever b is. If b is negative, then fine, it's a negative negative. Over 2 times, what's a? Negative 1. Negative negative 2 is positive 2. 2 times negative 1, negative 2. 2 divided by negative 2 is negative 1. The AOS is negative 1.
So where did this come from?
To find the vertex.
Okay, okay.
The vertex, we already know the x value is going to be negative 1. I take this negative 1 and substitute it in. Negative 1 squared minus 2 times negative 1 plus 3. Notice that instead of putting just negative 1, I'm putting it in parentheses each time. What's negative 1 squared? 1. Throw a negative on it. What's negative 2 times negative 1? 2. And then I have plus 3. All right, put my positives together. What's 3 and 2? 5. 5 minus 1 is? My vertex is negative 1, 4. Most mistakes here were made because of this. What's your y-intercept? 3. Reason why? It's by itself. Now, something we've already talked about and mentioned briefly. If it's a minimum value, it's going to open up like this. This point here, your vertex is your minimum. If it opens downwards, your vertex is your maximum value. When we're talking about domains and ranges, for both of them, the domains are all real numbers. The y values, if it's opening upward, the y's have to be greater than or equal to k. If it's going downwards, it has to be less than or equal to k. I have negative 3x squared plus 2x minus 4. We need to determine, is it a max or is it a min? So to tell if it's a max or a min, you need to look. Does it open upwards or does it open downwards? It's going to open downwards, so that means this point is a maximum. Now, the domain, we already, that must be on the next one. Find the x value of the vertex. That's the negative b over 2a. The domain would be all real numbers. The range would be y has to be less than or equal to whatever your k is.